All right. So we've already talked a lot about the waterfall approach to software development. One of the things is after I made those lectures, I talked with a colleague, Charles Clark, over in computer science. And we were talking about, teaching about waterfall and stuff. And I kind of feel like I might have been almost too forgiving to the waterfall approach, saying that something along the lines that if you have the right sort of engineering practices, it might just work. It might just be fine. And Charlie basically, he had a really good point. And his point really was that, the chances are where you find that the waterfall method actually seems to work, it's most likely that actually hidden behind the scenes or unbeknownst to you, what has really actually gone on and what has really actually happened is that you've had the team working for a really long time, doing lots of experimentation, lots of iteration in actually trying to figure out what is going to be the right specification. It's this illusion that we're going to go talk to customers, we're going to observe them, and we're going to write down the requirements and get people to sign off and have it work is an illusion. It is, okay? What really you're going to need to have is you're going to be making prototypes, you're going to be trying things out, you're going to do lots of work, much in the same way that you might be with Scrum or an agile process, iteratively working on your design. You're probably going to be doing lots of stuff to really try things out and so forth and so on. And eventually, through all of that experimentation and all of that iteration and work, then you're able to lay out what the software requirement specification and your design spec really are. But to say that it's just this really nice, clean, we came up with the spec after talking and observing users, that's just going to end up being one really big first iteration. You're going to build some piece of software, you're going to find out tons of things that you didn't do right with it, and then you're going to have to do another iteration to fix all those things, and probably one more again before you really get it right. So that's the thing to keep in mind is where it seems to work, it probably is the fact that you actually had done a lot of other work in advance. Then the other time that it might actually work is when you're actually called upon to do a piece of software that's highly similar to software that you've done time and time and time again. Part of me, this sort of reminds me a bit of people building houses. Houses don't differ that much from each other, and a lot of houses are actually, in a neighborhood, highly similar to each other. They're just sort of spread out and put in different places by the builder. So there's some small modifications that the architect made, but a lot of it is highly similar. And so they're able to estimate things pretty well and be able to nail when things are going to be done. But if you look at other large engineering projects of things that have never been done before, they have lots of setbacks and problems often as well with the waterfall approach that is used there. So it has a lot to do with the nature of engineering design. It's hard to get it right the first time. And so if you are going to succeed and work with it, usually what you're trying to do is find low-cost ways to iterate and experiment to figure out what the right way is. Scrum, these other agile approaches are nice from the standpoint that you're very carefully going to incrementally grow things and respond and change over time. If you're going to be using a waterfall approach, you really should actually be saying to yourself, wow, this planning phase needs to be really major, and the planning phase really should have in it quite a bit of trial and experimentation, prototypes, and other things, rather than thinking our planning phase is only about writing documents. All right.